a lot of this is going to be demo. For those that don't know me, I'm Dan Walsh. I lead the container runtime teams at Red Hat. We work underneath OpenShift. We do everything in containers underneath the Kubernetes level. So my team and my job is to experiment and work on new technologies to make running on top of Kubernetes and OpenShift better. And so last year I came. How many people were here last year and saw me talk? Okay, so I'm going to go over some of that. I didn't want to repeat last year's talk, so I'm going to move this more towards a demonstration of some of the technologies we've been working on and we've added. So in OpenShift 4.0, we're moving to cryo container technology. I'm actually going to kick off a little bit of the demo right now because the first step of it takes some time. So we're going to be demonstrating different tools here. This thing will not stay. We'll be demonstrating. No. Okay. We're going to be demonstrating Builder, Podman, Scopio, and Cryo, and security. And we're going to start by doing Builder. Okay, so that takes a couple seconds. I'll blame it all on my foot. Okay, so anytime I do a presentation, I always like to get the audience involved, so everybody stand up. A little stretch, right, before your coffee. Okay. So anytime you see text in red, I expect you to read it out loud. Red. Excellent job, and try to be coordinated, so.
I promise to say make coffee rather than make a Xerox. I promise to say tissue rather than Kleenex. I promise to say container registries rather than Docker registries. I promise to say container images rather than Docker images. I promise to say containers or OCI containers rather than Docker containers. Sit down.
So as I talked last year, I talk about what do you need to be able to run a container. First of all, you need a container definition, and luckily for us, that has been standardized. There's a standards body called OCI, Open Container Initiative, that defined what a container is, or what a container image is. And it's a tarball and some JSON file, and the JSON file sort of describes what's in the tarball, right? It describes things like environmental variables to use when running the container, the entry point, the actual executable that you're going to be running, and really that's all containers are, is these tarballs and these JSON files tied up together and stored out of container registries. Container registry is nothing more than a web service. Okay, so it's just a web server, and there's basically web protocols interacting between those. The second thing you need to do when you run a container is actually pull that container image, the OCI image, from the registry to your host. Okay, so we needed a mechanism for pulling that down, and we have built a library for that called containers image. It was based on a tool I'm going to be showing later on called Scopio. So Scopio implemented all the protocols needed to be able to pull container registries to the host, based on basically the Docker technology, what Docker had invented for pulling registries. But we have a separate library for being able to do that. The next thing you need to do when you pull a container image to the host is actually take the container image and put it onto a disk. Okay? Containers, images tend to be layered, right? You might have heard of the concept of layered containers. And in the layered containers, you basically have sort of a base image, and then I put some modifications to the image. And usually it's just the difference between the original and the modification is what we're shipping. And then I might have a third layer. So think about, I might have a RHEL 7 image, I might have Apache web service running on it, I might have JBoss running on top of that, and then I might have an application on top of that. So I have a 4-layered container, right? I have the base image layer, the Apache layer, the JBoss layer, and then the application layer. So when I ship out my image, I want to run that application, but when that application is pulled down, it's pulled down as 4 different images of really 4 different layers. So each one of the layers come down. When we're storing that on disk, we have to store it on top of what's called a copy on write file system, or a layering file system. And so what happens when I copy it down is these layers get created. Usually layering file systems are things like Overlay, Device Mapper, or Btrfs. And what we did is we created a library to be able to handle these. So we have container storage. So container storage is a Go library that basically supports Overlay, Device Mapper, and different types of storage. So I can have a definition of an image. I can pull it to my host, I can store on disk, now I need to run it. So the last step of running it is we needed a standard mechanism for what it means to run a container. And when I'm running a container, I'm really talking about taking input from 3 different entities. We have the OCI image, right? Remember I told you it had that JSON file associated with that sort of has definitions of what it means to, what that container is, the intention of how to run that container, entry point, environmental variables. Then we have the tool, or the container engine, that pulls down the image. It has inputs, so it has hard-coded things like, generating SE Linux types, or what capabilities are going to be defaulted to on or off, and different, maybe seccomp filters, things like that. And then you have the user input, right? So anytime you've run a container engine, you basically have given an input. I want to run in privileged mode, or I want to run with these additional capabilities. So you need to take those 3 inputs, right? The image, the tool that's pulling it, and then the user input, and combine them together and somehow describe what you intend to run a container as definition. And that thing that gets created then is called an OCI runtime specification. It's another JSON file. But we needed to have a standard JSON file that container runtimes then could interpret. So a container runtime is a tool that reads that JSON file and talks to the Linux kernel and says, I want to do this, right? I want to set up these C groups. I want to set up these security separation. I want to set up these namespaces. So we have these 4 things to run a container. But the big thing to understand here is there's no requirement for a big fat container daemon to do any of this stuff. Okay, we have a standard definition. Anything that sits at Docker.io, Quay.io, registries.redhat.access.com, whatever the Google one is, they've all been standardized. We don't need to have a daemon always to run that. And the problem with the daemon is that you end up with all these different use cases, and we're going to be talking about the use cases in a minute, end up going through a common denominator, right? A common tool, and you end up with the least common denominator of security, right? If I have to use one daemon for running containers in production, and the same daemon for building containers, and the same daemon for playing with containers, how do I set up the default security that that entity is going to provide? Remember, I talked about the middle entity is providing what security, it has input to what it means to run a container. So what we want to do is we want to break apart that into sort of 4 different categories of container management. Okay, the first one, we want to be able to build containers. Right? You want to be able to build container images. Second one is you want to sort of run and play and develop the container images. The third one is you want to store and share them. So how do I move things around? And then the 4th one is running containers in production. And I argue that each one of these steps has different security goals. Right? There's real different security required for each one of these steps. And if we go back to the history of Unix, the whole Unix philosophy was to do things simply, right? Simple things, and each one of them, unique and do them well. So what we really wanted to do is break apart sort of what was the traditional way everybody was running containers into these, subcategories and subtools. And so the tools we're going to be showing and demonstrating today are all being slowly built and organized into OpenShift. So when we're building containers, for build, there's a tool called Builder, okay? And it's making fun of my Boston accent, but basically it is a container builder. The second one is if I want to run and play with containers. How many people have heard of Podman? Okay, whole bunch of you, excellent. Okay, so Podman is all about sort of playing the developers. When a developer needs to build containers and stuff, Podman is a tool. The next one's a tool called Scopio. And Scopio really is just a tool, I like to think of as like rsync or SCP. It's really a way to move these container images around. right, to move container images from external registries. Say you have you only want your developers to work with your internal registry. Well, you need a tool to copy potentially from external registries into your internal registry so you can develop with them. And then the last one is running containers in production. And to me, that's the one we really need the tightest security on. And that's, obviously in this case, is Cryo. And in OpenShift 4.0, you'll be getting Cryo as your container runtime engine, and you'll get Builder is built in. Builder is really a library for building container images. So when you're doing your source to image, it'll be using Builder underneath the covers. So let's take a quick look at Builder, and then we'll get into the demo of it. So one of the key things to understand about Builder, or one of my goals when we developed Builder, was to really look at shrinking the attack surface of a container. So container images, microservices, are developed in such a way that theoretically, if you need to upgrade a image or update a container image, you should be swapping it out. You shouldn't go into a container image and do a DNF update. Okay, that is an anti-pattern. What you should be doing is, say you have a CVE and a library that's included in an image, you put in a new image on top. But because of the way Docker files were built, you have to have DNF and YUM inside of the container images. Okay, that's just basic. So the images have to have all the tools used to build the image have to be inside of the image. Or you've got to get complexity like multi-stage building and all this hacking around to get it in. What I wanted when we originally were looking at Builder was just create a directory, allow me to put content in it, tire it up, and push it to a registry. Do it that simple, right? All container images is a directory and some JSON file. Well, why can't I just build that and push it to a registry? And so that's something Builder allows you to do. Other things that we can do with Builder now is build in isolated containers and run without root. But let me show you that rather than talking about it. So luckily, this is all finished. So right here, oh, good, you can't see it. So at the top line in the blue there, it says Builder from scratch. So what that's doing is it just creates a directory on disk and it creates a Builder container. You can see working container 3 after I enter my password. And then we're going to mount the container. So that basically I'm mounting up, creating a directory on disk, and then we're just doing a DNF install here. So there's a DNF install line there, and its install root is mount. So that's the mount point that I created on the system. And I'm just installing BusyBox from Fedora 29. And basically, so I started out with nothing inside of the container, and I just installed the package that I wanted to be inside the container. And that, because of slow internet, has happened in the background. So now I'm unmounting the container, and now I'm going to try to, I'm going to create a container image off of it, and at this point, I'm going to run ping inside of the container. Oh, that's weird, that failed. Oh, that's right, ping doesn't exist inside the container because I didn't install it. I'm going to run Python inside the container. Oh, that's right, Python doesn't exist inside the container. The only thing inside of this container is BusyBox. Right? There's no special tooling. This is using the same libraries you already have, but if you want to create an image that has as little as possible inside of it, and I'm talking about the number of packages, this is the way you could do it. And that's BusyBox running inside the container. Okay, so another interesting thing about Builder being separate is that Builder can actually be run inside of containers. And this is actually what OpenShift 4.0 is going to be doing. It's actually going to allow you to run builds inside of your OpenShift environment. But unlike OpenShift 3.7 and everybody else in the universe, we're not leaking the Docker socket into the containers. So we don't have to run every single container that does a build doesn't have access to the Docker socket. And by doing that, we increase the security of the systems. So here is actually, we're using Podman here for the demonstration, but we're actually, if you look up here in the sudo line in blue, which just scrolled off the screen, it's actually running a container. So Podman's running a container. I took some directory in my volume, but basically I created some storage, and I previously built a Builder container. So I'm running the builder container inside of a container. It's pulling down Alpine and basically executing that Docker file. So now I have a builder container. Basically, I've just built a container inside of a container without leaking any kind of socket in, and basically done it inside of a secure environment. So let's go back. So that's an example of some stuff you can do with Builder. Oop. Okay, so now we're going to look at Podman. So Podman is a replacement for the Docker CLI. It allows you to do pretty much everything that the Docker CLI can do, or at least that's our goal, except for things like Swarm, because we're in the Kubernetes community. But pretty much every command that you've ever executed with Docker, you can do with Podman. But it's interesting that we can do them all without root. We can isolate better with user namespaces, and we're going to show you some features of audit that make it more security, and of course, no big fat demons. But I actually gave a talk. We were at the Brno this past week, and I gave a talk, and I'll extend my time a little to try to get through this talk. So replacing Docker with Podman. And guys, what happened with the red? You guys are sleeping out there. All right. So the first thing, if you want to replace Docker with Podman, you do DNF install Podman. Everybody got it so far? Then you do alias Docker equals Podman. And the next step is, any questions? It was a very short talk. Okay, and the way I proved it is that this, by the way, this came out back in May 29th. This Alan Moran tweeted out, I completely forgot that 2 months ago, so back in, when's that, April last year, I completely forgot that almost 2 months ago I set up an alias of Docker equals Podman, and it has been a dream, no big fat demons. And down here, Joe Thompson asks, so what reminded you? And he says he executed Docker help. And of course, I came up and gave him Podman help. So let's go look a little closer at what Podman, some interesting features of Podman can do. Okay, so if you see here, the Podman command up the top there doesn't have the word sudo behind it. And I'm not cheating, there's nothing going on behind in this script. It's actually going to run Podman as non-root. So it just showed you the images that are in my home directory versus images on the system. Oops, I misspoke a little bit. So yeah, the previous one showed you images in my home directory and then images on the system, so the ones with sudo in front of it. So you see there's a totally different list of images. So when I'm running Podman as non-root, I'm actually writing the images to my home directory. So as you get your developers come to you and say, I need to run Docker. I need to run Docker on the server to play with the container images there. You can say, no, you can use Podman, and I don't have to give them access to the Docker socket. So now I'm going to actually run a container, and this actually shows. This example we're doing is we're running a container and we're showing you ID. So when I run the container, it says I'm root, and if I execute on the host, what it is, I'm dwalsh. So basically the same command executed both of those, but I'm fooling it into thinking that it's root on the host. So how's this happening? So there's a file out on the system called etc subuid. All right, and every modern Linux system, anything more modern than RHEL 7.6 has this now. We will have in RHEL 7.7 everything I'm about to show you, so that's coming out in the summertime. And it's not to do with our container tools, it's actually we needed a new version of Shadow Utils to be able to do this. So there's a file on disk called cat etc subuid, and you see up here it has dwalsh, and it basically says that not only am I going to have my UID ability to use it, but I'm also getting these UIDs. So I get all UIDs from 100,000 to 165,536. So basically the system is now allocating lots and lots of UIDs for each user that gets added to the system. Now if I look at my directory I'm about to run this test on, that's what my directory looks like. And you notice in the third file down there is a file owned by root. Okay, probably not a common thing to have root inside of my home directory. But now I'm going to do a builder on share, and I'm going to look at the same directory. So builder on share actually puts my account into a user namespace. So it's switched. Now, still, this is not privileged. I am not real root on the system. I am root inside of my user namespace. But you see the file that is owned by root now becomes nobody. and all my files now become root. Okay, and that's based on basically what's happening here is I got to put it into a user namespace. So when I run podman or builder as non-root, I am being stuck into a user namespace that says map UID inside of my namespace to 3267. Remember, that's my UID. So that's when I log into the system, and it says map one UID to that. Then it says, starting at UID 1 inside of the container, map 100,000 for the next 65,000. So I have basically 655,036 UIDs that I can now play with. So I can create files that are owned by 1 and 2 and 3 and 4, and I can install software that might come with Apache owned by UID 60. Inside of my home directory, it's going to be mapped, the UID 60 would be mapped to UID 100,059. Okay? But basically that's what's going on inside of user namespaces. So we can use Podman to run containers inside of a user namespace in your home directory, but user namespace was always garnered at basically giving me container separation. So if I run 5 different containers, all in different user namespaces, I can actually use UID separation to separate them. These are things that we're looking to add to Cryo to make our OpenShift containers more secure. So here I'm going to run a container. Now I'm running with sudo, but now I'm going to run a container, and this time I'm mapping 100,000, or mapping 5,000 UIDs, starting at 100,000 to a sleep container. And this is an interesting thing that Podman also has. It actually has the ability to show you, show the process inside of a container and how they're mapped. So I'm mapping root inside of the container to UID 100,000. So Podman top now takes the flags of user and HUser. So it shows you the user inside the container and outside of the container. And I'm going to show you that's actually the container. So that's just a standard PS command showing you that it's running as UID 100,000 outside of the container. Now I'm going to run a second container as UID 200,000. I'm going to show you this PS. So now I have 2 containers, simple as that, running on the system, each one in a separate user namespace. That means if either one of those containers breaks out, it's going to be UID 200,000 attacking UID 100,000, not real UID root attacking it. So this allows you, as we add this functionality to Cryo, all of a sudden we can start to launch each container in a separate user namespace and give you better security separation. One last thing about Podman versus Docker. Podman uses the fork and exec model. So anybody ever know what login UID is? No security people out there. Okay. So when you log onto a system, there's a flag set in the first process system to say you are Dan Walsh. And no matter what I do, sudo to root or anything else on the system, it will report that I am Dan Walsh. So we can track what the user does on the system. So if that is set, login UID, and root can't change it. So now I'm going to execute a command as part. I'm going through sudo, so I'm becoming root. So that's another shell. I'm executing podman. Podman is then executing a container. So I am now 4 levels away from the login user on the system, and yet it still reports that Dan Walsh did this, okay? If I do the exact same command underneath Docker, it reports that it was done by 42 billion, or 4.2 billion, whatever that number is actually -1 in a 64-bit number category, okay? So what's happened here is Docker is a client-server operation. So I am a client talking to a daemon, and the daemon actually is exec, right? That's the big fat daemon. And when it execs, it was never started by a user, right? It was started by the init system, so therefore it's reporting that it was started by nobody. So now why is that important? Let's put an audit control that watches who's modifying Etsy Shadow. So I just ran a container that modified Etsy Shadow. So here we say turn on auditing. Next line is I mounted into a container, the ability basically slash mounted at host, and then I touched host / Etsy Shadow. So I modified Etsy Shadow on the host. If I log into the container, if I then look at the auditing subsystem, it reports that who modified Etsy Shadow? D. Walsh did, right? Now if I do the exact same command, modify Etsy Shadow with Docker, it reports, instead of it being dwelched that did it, that it was AUID unset. So if you give your users the ability to talk to Docker daemon, they can do things on your system that you have no idea who did it on your system. They can also remove the logs that basically, all the Docker logs get removed when you destroy the container. Last couple of top features, Podman features, basically, I can see things like the PID on the host and the PID inside the container. I can see what SE Linux labels are associated with it. I can see whether seccomp filtering is turned on. I can see some capabilities. This is going to come up in a minute, but notice these are the default capabilities that Docker runs by default. So this is sort of, Docker established what it meant to run a container when you're doing in development, and they came up with this list of capabilities. Now, for those that don't know what a capability is, in Linux, they've divided the power of root into about, well, there's room for 64 capabilities. I'm not sure the exact number at this point, but there's like 40 or 45 capabilities. When we run containers, we drop that number down to, I don't know, there's about 12 or 13 of them up there now. Okay? But these are the capabilities that are required to do things like building or to playing with containers. But when I'm running in production, I don't want all of these. So for instance, make node. When I'm running in production, I'm not creating device nodes in the system that I do when I'm doing builder. I don't need to do the auditing writing system, and there's a couple others in there. So when we run in Cryo, we're going to cut down on the number of capabilities in it. This list, no one knows unless you're a developer and actually looked at the code because it's not revealed. So we wanted to reveal to users what's actually going on inside of the containers. Let's go back to quickly the presentation. Okay, so Scopio, I mentioned in passing in the beginning. Scopio originally was about inspecting remote images, looking out at a container registry and getting down. When you do a Docker inspect or a Podman inspect, you get that JSON file that sort of describes what the container is, container image is. What we wanted to do is basically go out and look at a registry and download that without having to pull the image to the local system. And then you're able to move images between different types of environments, and it runs without root, right? There's no reason for root. I'm just moving these blobs if I can move from one repository to another repository, I don't need to pull it in and make it root in the system, right? I don't have to save it anywhere. I just move it back and forth. So here is, that's a Scopio command, and right now I'm basically going out to Fedora, and this is actually pulling down the JSON file. So that's actually never pulled the image, never pulled the Fedora image, is not storing in a local disk, but basically pulled down the JSON. If you just want to look at the JSON that's associated with an image, you just do it. So this is actually kind of, so here we have the list of Podman images. Well, I should have removed the Ubuntu image, but anyways, here's the list of Docker images. And what I'm going to do is Scopio actually has the ability, and all the tools have the ability to do this, to transfer between different types of container storage. And so I can copy from container registries, but in this case, I'm going to copy an image directly out of the Docker daemon into something Podman can use. Okay, and this might be, as people are looking to convert from Docker to it, you could actually use Scopio and run through your container images, and what this is doing is pulling directly from the Docker daemon and now storing it inside of, basically inside of something Podman can use. So you can actually move between container storage, two directories, registries, everything else. Scopio has all that built in it, but Scopio is using containers image, which means that Builder, Cryo, and and Podman are also getting the same type of functionality. Okay, so Cryo. Cryo is, if you've seen last year's presentation, I go into major pounding away that Cryo is all about love for Kubernetes. It services just Kubernetes. We had it this past week, where the reason I'm in Europe is we had this huge conference in Brno last week called DevConf. And one of the talks there was talking about how Cryo is tested. Cryo right now has 15,000 tests running on every single PR. If you want to change Cryo you got to pass 15,000 tests. Every single Kubernetes test, every single OpenShift test, every test we can imagine. There's a thing called access. We just take all the tests. We're testing it on top of Ubuntu, on top of RHEL, on top of Fedora. We also embed Kata container tests on top of it. So we basically want to make absolutely positively sure that we don't break Kubernetes. All right, that's why it's totally dedicated to it. But we also want to add security features to CRI-O to make running containers in production more secure. I personally believe that all containers in production should be run as read-only. You don't want your containers writing to /user. As an example, we want to enable fewer capabilities. Again, as I showed you earlier in Podman, the list of capabilities that we allow by default. We want to start taking advantage of user namespace, and we want to do things like make our government customers happy by actually implementing FIPS mode all through the stack. So other people are talking about FIPS mode, but you got to make sure FIPS mode works at every level of the stack, all the way up to the containers that are running inside of your container runtime. So we're going to show you basically how to turn on container on basically read-only support inside of containers. So I'm using CRI-CTL for this demonstration. I'm not using full Kubernetes or full OpenShift. CRI-CTL is the tool that mimics Kubernetes and just makes it easier for demonstrations. So we turn on, we had the read-only flag off. We actually edited and turned on the read-only flag. And now I'm running a container as you would run underneath OpenShift with the read-only flag turned on. There's nothing in the container image to say it's read-only. And then I try to install an image on top. I try to install into it, and it gets a failure because basically it's a read-only image. So you don't want containers able to modify themselves. All right. The only thing containers should be able to write to is temporary file systems and volumes that are mounted into the container. So we talked earlier about capabilities, and you saw previously the list of capabilities that are on by default inside of Podman and inside of Docker. In CRI-O, we expose to you the capabilities that are running inside of your containers. So you can go in here and actually modify container capability. So if you think that I'm never going to run a container that requires sys-chroot, I can turn that off just by editing that. So what I'm going to do is I'm going to go in here and edit sys-chroot. If anybody interesting, I could talk about what these capabilities allow you to do. By the way, everything I'm talking about, stepping back and forth, if you just run as non-root out of the box, run all your containers without requiring root, you don't need these. But I know some of you are going to run some containers that require root. So if I'm going to just do remove that from the container, I'm going to restart CRI-O. And I'm going to go in, and if my demonstration worked right, I should no longer see cap shown on the list of capabilities up there. So you have now, with CRI-O, you have the ability to choose what level of security, what kind of containers you are. But with ability comes great responsibility. You break it, you own it, okay? But anyways, you can start to examine and look at how you want to secure your system, and basically can start to define, I'm not going to allow these capabilities inside of my containers. By the way, Kubernetes can always override that, but now Kubernetes has to request the override the capabilities. Okay, this just shows you a list of all the capabilities that are available inside of the container now that we've made this change. Okay, so that is basically the end of the presentation. As you can see, we're taking advantage of different tools, breaking it apart of which tools do which function well, and then concentrating on the security of each one of those functions. We're also experimenting at the low levels, trying to figure out how's the best way to use user namespace inside of Podman. Once we're comfortable with that, we actually move that capabilities into CRI-O. right? Start to look at, can we move those into cryo? And by the way, for everybody taking pictures, at the top here, the slides are available, and everything I demo from now on is always going to be in GitHub. So if anybody wants to try these demos and prove that I am lying or I am not, we're putting out all the demonstrations, so all these scripts, and all my team is putting out any scripts we're doing online. Plus, you'll have this. So I guess no questions. You can ask me questions later, or is that what you want to do? Over coffee, yes, I will be around. I am not allowed to leave. All right, thank you.